Hello and welcome to the March update from the TauNet team. It's a developer update, so over to you, Karim.
Thank you, Fola, and welcome everyone to the March update for the Tau development team. Let me start with Andrei as usual. Andrei has been making great progress towards the implementation of testnet and the Tau blockchain in general. He's been developing interfaces to external libraries such as the P2P lib and the cryptography library. He's also started outlining the initial implementation of the Tendermint protocol, which is the proof of stake protocol. And we've been discussing which features of that protocol in particular will be initially changeable by the Tau users. So interesting progress on that front. David has been working both on a solver and on bit vectors. On the solver side, he used an algorithm of successive elimination to compute minimal and maximum solutions in Boolean algebra. He also added tests to check for the correctness of those solutions and made fixes to the LGRS command and the CLI. And on the bit vector side, this is a major new feature for Tau language that is critical for TauNet. So he's initially defined the grammar for bit vector constants. He also defined the grammar for arithmetic expressions for bit vectors and has started on the actual implementation of those operations, relying on the Z3 SMT solver by Microsoft. Lucca has been working on pointwise revision. He actually completed pointwise revision, which is the most important feature of the Tau language that allows for changes of the code over time. He implemented interfaces or type inference for input and output stream variables, converted recursive calls into iterative calls because he ran into some stack overflow issues. I'll let him tell you more about that. And then he performed some extensive performance bottleneck analysis, which resulted in some solutions. But, as we all know, performance will always be, a challenge in Tau just because of the nature of the beast, basically. Several general improvements and bug fixes throughout the code. And he also, in cooperation with Tomáš and Umar, defined the API for the new tree traversal API, basically. Tomáš improved some error handling when normalization failed. He made some changes that added time offset to the arity to the signature of references such as functions. He fixed parsing of SBF conjunctions without a separator. There was some ambiguities there that he had to resolve. He created the Docker file for Tau, including the tests and the building of release packages. He revised the versioning convention and created a version file that contains the target version. He added the GitHub release flow that actually will make available the latest releases and the latest nightly builds to our user community, which is a feature that hopefully will be enjoyed by many of our members, so they can have ready-build versions of the latest Tau interpreter. And he's has some ongoing tasks he keeps working on, which is variable type inference. Everybody was involved in that this month. It's an ongoing task. But more excitedly, he has started working on the Tau playground, which is similar to the TML playground for those of you who remember TML, which will allow also our users to be able to play with Tau right from a web browser. Last but not least, Umar has wrapped up the last issues with garbage collection and deletion in garbage collections. He established some baseline for performance and a set of KPIs that we can reference in the future to make sure we're actually making some improvements on that front and no regressions. As always, he fixed some bugs and added tests to the parsing and traversal of the trees. And as I mentioned earlier, he also helped Tomáš and Lucca create a new API for the latest tree implementation that he did. That's it, Fola. That's it for March. See you next month.
Lovely stuff, Karim. Thank you so much for your overview there. And I'll pass it over to Andrei for a follow-up there.
Hello, everyone. I'm here to share some of the progress I made with the Tau blockchain over the past months. This month was basically all about using external libraries from Tau interpreter into Tau code, and we together with Ohad decided that the best approach is to use APIs as inputs and outputs for those libraries. So with that idea at hand, I have written a detailed interface description for library P2P with carefully aligned certain inputs and outputs. For example, I sent to output of library P2P connect to a certain node, and then I get an input from that library that node is connected and do some logic with it. So with that description, I wrote the foundation of networking for the Tau net. It's node discovery, exchange of node peer lists, and handshake, checking key, peer IDs, all that stuff. And I got to the point where we need to describe a consensus algorithm, and I wrote the skeleton, the basic parts of proof of stake algorithm using this library P2P. And we actually in a heavy development and discussion with Ohad on a more precise and Tau implementation of this consensus algorithm. Also, I have to run through the code again and again because we through the whole code of the blockchain, because we must be sure that all inputs and outputs in the code are carefully placed, as everything between inputs and outputs are meant to be changed by users of the blockchain, and this is the general idea. So that's it for this month. Thank you for your continuous support and enthusiasm. I can't wait for the next months where the development leads us. So stay tuned, stay connected, take care. Bye.
All right, fantastic. Andrei, I'll pass it over to you now, Tomáš. Cheers.
Thank you, Fola. Hello, everyone. In February, I've been working on fixing bugs. I was working on continuous integration and continuous deployment. I was working on building Tau for JavaScript and WebAssembly, and was also improving Tau by adding type inference for constants and variables. So namely, I finally pushed all the changes regarding recurrence relation signature. So it consists of its name, argument arity, and offset index arity. I fixed the bug, which I've introduced by recent changes in grammar for simple Boolean functions. It was causing errors when traversing conjunction without a separator. Then I've improved error handling when a normalization fails because of type mismatch or syntax error in bound constants. Then I've created a Docker file for Tau language codebase. If you have a Docker installed, you can simply build an image from a provided Docker file, and you can run Tau inside the container, or it can also run debug or release tests, and it also supports building release packages. I've added a GitHub workflow for creating release packages. I've added a GitHub workflow for creating automated nightly release packages. which is already enabled. So already now you can go to download the latest nightly and try the latest changes. I've also updated GitHub workflows for debug and release testing so they use the created Docker file and the Docker image. So we run tests in the same environment as we have when we are releasing packages. And we've started to use semantic versioning, and I've added a version file to contain the actual version. And then I've been also working on inference of Boolean algebra types for constant and variables, and I've started to work on mscript and build for Tau to enable running it in browser or Node.js. That's all from me this month. Thank you.
All right, fantastic, Tomáš. Excellent stuff. I'll now pass it over to you, Lucca, for your update this month. Cheers.
Thank you, Fola. Hello, everyone. So this month, I've been working on finishing up the core features of pointwise revision, which is an absolute necessity for the demo, which we are working on. The main idea is that during execution, so during the execution of a specification, there's now a dedicated update stream available in which you can write, and everything that's written into this update stream will be in a special way, namely using our pointwise revision algorithm, let's say joined with the current specification, so that in the next step of execution, you get, if possible, a fusion out of the two specifications in a logically consistent way. I think this took most of the month. For the usability of the execution of specifications, I have also implemented an initial type deduction algorithm. Yes, due to this type deduction algorithm, you no longer have to explicitly type input and output variables, but they can be inferred from constant types, where the tau type is assumed as a default type if now no type is found. Then another branch of work was the conversion of our recursive tree traversals to iterative versions, as Karim has mentioned, due to stack overflows, which we were experiencing, because some of the algorithm used to solve certain logical formulas are not fully optimized yet, and for this reason, formulas which have certain shapes can explode so much that actually the recursion depth of those formulas becomes so huge that the stack memory is not enough to save the recursion trace, and for this reason, we ran into stack overflows. Now these stacks are carried out on the heap, and this is not a problem anymore. And somewhat adjacent to those tasks, I've been analyzing further performance bottlenecks and investigated where they're coming from. And this gives an outline on what I will be working on next month. And beside this, just usual bug fixes and general improvements of the code everywhere. And yeah, that's been my month. Thank you very much. And I'll pass it back to Karim.
All right, fantastic. Thank you so much, Lucca. And now I'll pass it over to you, David. Over to you. Thanks.
Thank you, Fola. Hi, everyone. This month I've been working mostly in improvements on the solver related to the computation of the maximum and minimum solution. And also I've been working in the implementation of bit vectors. That means adding bit vectors as a new Boolean algebra into the Tau language. More precisely, regarding the improvements on the solver, now we use successive elimination to compute maximal and minimal solutions. And I have a test to check everything. And also I have made a few minor fixes in some of the commands that call the solver or parts of the solver. For example, the Leeuwenhoek general reproductive system command. Regarding the implementation of bit vectors, I have started by just creating the grammar that we will use in the typing of constants of bit vector constants in the Tau language, and also I have made a few changes in the Tau grammar so we could support arithmetic operations when dealing with big vectors, because at the end the idea of having big vectors is to have arithmetic, the possibility of computing with numbers in the Tau language. Apart from that, from the, let's say, the internal side of the Tau language, I have spec'd out the Boolean algebra for bit vectors, and the idea is to forward all the operations into the Z3 SMT solver from Microsoft. And I have made a huge refactor of all the parts that deal with how we work with Boolean algebras in the Tau language. In particular, I have split a lot of the code that we have in the definition of the Boolean algebra in such a way that it's easy to add more Boolean algebras, in particular that of bit vectors. And that's right now what I'm working is in adding the factories for the bit vector Boolean algebra. That means create the basic stuff to be able to work in Tau with bit vectors. And that's all for my month. Back to you. Thank you very much. Back to you, Fola.
Wow, what an incredible month. Huge month from all of you guys. Umar, over to you.
Hello, team. Glad to share the March update. During this month, mostly the work has been on improving the garbage collection, especially fixing some of the issues with the deletion of garbage as we collect it. That has been corrected, and also the number of items that we can collect has also been improved. Um, we also now include the tests that can check how the improvements have happened over the different versions of the same binary. Other than that, several benchmark tests have been added, and now there's a Python script that we will be checking in that can take the diff between the stats of two test logs and can help us in visualizing what got improved. So both of these changes will be checked in the master branch. Thank you for that.
I'll end it up with Ohad. Over to you.
Yeah, so this month I continued with what I spoke about last month, which is enhancing the temporal abilities of the Tau language to reach the level of LTL and maybe beyond, not in model theoretic sense, but in complexity sense. That's a little bit a delicate point. And you could say I'm finished or almost finished. The LTL part. So I have to finish it and then to go to the beyond part. And then I will have to outline the algorithms for the team to implement. And then we will have even richer software specification language. And it will also be much more appealing for people from academia, because it's not going to be something completely new and different. It's going to be something that is easier to compare to something that they already know. And I was working on the demo. Every time I worked on it, I hit bugs, whether correctness bugs or performance bugs. So this is currently a bottleneck for me to show a simple demo of something non-trivial. But yeah, we are not that far from it. Once the bugs are resolved, we'll prepare such a simple demo. That's all.
All right. You heard it from Ohad. Thank you all very much for tuning in. As always, please follow us on our socials. That's on X. That's Tau_net. And that's also on Reddit. That's TauNet Agrs. And on Telegram, it's TauNet. All right, guys. Thank you very much. Cheers and enjoy your month.